exercise. These are pretty much incalculable with I guess, standard calculators. But anyway, what I want to show is that this huge number, 283 factorial, divided by another huge number is actually just a natural number, meaning a counting number like 1, 2, 3, 4, 5, 6. All right. Now, what I'm going to do to get started is just motivate the idea behind this using a smaller case. Now, we're just using 13 factorial, which is easy to write down and not a problem to deal with, really. So I wrote down 13 factorial, and I'm saying let's find the exponent. And y'all, this is just an example, again, to motivate how to solve this problem. So the highest exponent of 3 in the prime factorization of 13 factorial is what we're seeking here. Notice here we have 1 copy of 3, 2 copies of 3, 2 more copies of 3, and another copy of 3 here. Now this is actually just 3 squared right here, right? 3 squared is same thing as 9, right? So again, 1 copy of 3 here, 2 times 3 has 1 copy, 2 copies of 3 out here, and then you have 4 times 3, another copy. So you see, that's where we get this 5 right here, okay? And that's what I mean. By inspection, there are 5 factors of 3. They're all multiplied together and rearranged via the commutative property. And so we get 3 to the 5th is a factor of 13 factorial, all right? Now, but a nice way of looking at this using the floor function, which comes in very handy when you're dealing with larger numbers, right here, 13 over 3, okay, 13 over 3. Now, what does that really mean, the floor of 13 over 3? That counts the multiples of 3 that are less than 13, okay, and you can actually count them out. 3, we already see them up here, right? 3, 6, 9, and 12. Those are the multiples, right? Those are the multiples of 3 that are less than 13. And that's what the floor function returns. Notice, y'all, this would be 4 1/3. This is a floor function, so you lose the fraction, you get 4. Now notice that we need still to pick off, this is kind of insensitive to the 3 squared, right? It doesn't know that 3 squared is any different than the 3 and the 3 and the 3 here, right? So we picked that one off by doing the floor of 13 over 3 squared. And it's kind of subtle. I didn't see that at first when I first started thinking about this. But so notice you get 4 plus 1 is equal to 5, and you're going, yeah, right, that's not a big deal, you know, because we already did it like this. But again, when you deal with larger cases, it's nice to have this machinery in place, okay? Now let's move along and use this to actually help us actually solve the problem at hand, which is to show that 283 factorial over 745 reduces to a natural number. Now this, right, it's easy to see right here that 40 is the floor of 283 divided by 7, right? 7 times 40 is 280, and 3 is left over, right? So you chop off the fraction, if you will, you get 40. In a similar fashion, you're going to get 5 right here. Okay, you're going to get 5 right here. Okay, and again, 7 squared is 49. 7 squared is 49, and 5 times 49 is 245. That's less than 283. So the floor is definitely going to be 5, right? Now, technically, you got to keep going until you get to a floor of 0. So let's go ahead and do that right now. 283, it doesn't take, this is just a moment's pause right here. 283 divided by 7 cubed, even though you could almost not write this down because you know that 7 cubed is a larger number than 283. But 7 cubed is definitely bigger than 283, right? I think it's what, 343? But notice the floor of that is 0. 0 is the largest integer that is less than a fraction that's less than 1, right? 283 over 7 cubed is definitely less than 1. And you know that is a 7 cubed by my efforts, all right? So what we now know is that 283 factorial, 283 factorial is going to be equal to some huge constant, we'll call it m, okay, times 7 to the 45th. Now let me go ahead and put that in parentheses, 7 to the 45th power. 7 to the 45th power, ladies and gentlemen, is no doubt a factor of 283 factorial. But we're supposed to show that 283 factorial over 7 to the 45th is a natural number. So let's just write that down right here. 283, let me come over here. 283 factorial, which we know is some huge natural number times 7 to the 45th. Okay, 283 factorial divided by 7 to the 45th. Okay, is just equal to the m that we wrote down over here. Equal to m, which is certainly a natural number, okay? So this is really what we set out to prove. It's not constructive. Now you could, maybe you could spend a little more time if you wanted to actually get the value of m, but it's not really the point of the exercise. So again, folks, I just substituted 283 factorial is equal. I forgot to put the equal sign there, didn't I? So y'all, there is an equal right here. 283 factorial is equal to m times 7 to the 45th. So if you substitute that right there, the 7 to the 45th cancel, and you get this result right here. And we've proven what we set out to prove. All right. I hope you guys enjoyed.